Hello, I'm Antonio, and I'm going to present the work Combining No-Till and Slurry Application, Strategies to Reduce Ammonia Emissions. The interest for a more sustainable production system is increasingly in many countries. The use of solid or liquid manure brings several benefits to agriculture, such as nutrients, beneficial microorganisms, increasing organic matter content, lower costs, and higher incomes. However, the study recommendation is to incorporate the animal slurry into the soil just after its application. In conservation agriculture systems, like no-till, the soil disruption is undesirable, as well as the destruction of the stubble layer that covers the soil surface. Consequently, in those systems, manure will be applied on the crop residues. Therefore, it might lead to higher nitrogen losses by the increase in ammonia emissions. This uncertainty sometimes makes the farmer choose synthetic fertilizers rather than organic. The main goal of this work is to provide a better understanding of ammonia emissions from their slurry applied on stubble-covered soils. Also, to assess some strategies searching for reducing ammonia emissions from the slurry applied on crop residues. The experiment was carried out in a greenhouse at Instituto Superior de Agronomia in Lisbon, Portugal. The evaluated treatments were raw dairy slurry, acidified slurry to pH 5.5, irrigation right after slurry application equivalent to 10 millimeters, and ammonium sulfate. All these treatments were applied on the wheat stubble. One more treatment was the raw slurry applied below the stubble. Also, we had a control without fertilization. We used the dynamic chamber system to trap ammonia emitted from the pots in a phosphoric acid solution. The daily ammoniacal and emission rates from all fertilizers peaked on the first day and reached negligible values since the sixth day. Raw slurry and irrigation on the slurry presented the highest peaks. There were significant differences among the treatments over the cumulative ammonia emissions. Raw slurry emitted the highest amount of ammonia, followed by irrigation. The slurry application under the stubble and acidified slurry were efficient in reducing ammonia emissions. Acidified slurry emitted 66% less ammonia than raw slurry. In conclusion, acidified slurry and the slurry placed under the stubble were the strategies that allowed most reducing ammonia emissions from the slurry applied on stubble-covered soil, as a no-till. Strategies such as acidified slurry and the placement under the stubble, which provide greater slurry efficiency, can help to increase the use of manure as a fertilizer in conservation crop systems. Despite more studies being needed, our results might be useful for slurry application in other situations where the soil is kept covered, such as strips between fruit trees or cough bushes, and even forestry. Thanks for the attention.